All right, so good afternoon. In this session, we're just clearing up the understanding of the equation of a line. Now, what we have to recall is that every equation of our line, if it's a straight line, it's going to be in the form of y is equal to mx plus c. Right, so remember, your equation of your line could be y is equal to 2x plus 6. That can be a possible equation of this line. You can also have the possibility where you have a negative gradient. Right, so these are all equations of the line. So if they ask us to find the equation of a line, we want it like this, where you have the value of m, which is your gradient, and a value of c, which is your y-intercept. Now, no matter where you go on a straight line, right? So the equation will be the same throughout this line. In order to find the equation, we're going to need our gradient. Remember, the gradient simply means the steepness of the slope or the steepness of the line. So your line could be like this. Or even in the next direction at a negative slope, right? So your line could vary with respect to its gradient. Now, no matter where I go on my line, my gradient is always the same. Right? Your gradient is always the same. So if I were to be here, my gradient is the same as if I move to here. If I move to here, my gradient is the same as if I move to here. Your gradient is the same throughout. Hence the reason when you find the equation of a line and you have the gradient, it's going to be for the entire line. The next thing is your y-intercept. Look at this line. This line is only cutting your y-axis once. So that point where it's cutting your y-axis is known as your y-intercept, C. So what you'll realize is as you go along the line, the only thing that changes is the x and the y values. For example, look at this first point here in orange. My x value is 2, my y value is 1. Look at the second point here. My x value is 4, my y value is 2. Look at this third point. Remember, this line is formed by joining points on the line. That's how we form the line. If I were at this point, my x is 6, my y is 3. So the only thing that's changing is my y and my x values. That's why we can use any 2 points on the line to help us find that gradient of that line, right? So hence, we can use any 2 points on that line. Right? Remember, the gradient is your steepness of the line. So I could use any 2 points. So I'm going to use this point and this point here. You could use any 2 points. So when, like, let's say they give you a question to find the gradient. When they give you 2 points, it's like they selected 2 points on a given line for you to find the gradient and hence the equation. So let's say I took these 2 points. So let's say point 1, it has an x value of 2 and a y value of 1. Remember, this is how you write your coordinates of a point. And let's say point 2. For point 2, I have 2 points, 2 coordinates. Again, I have the x coordinate, which is 6, and I go across horizontally and I get my y coordinate, which is 3. So in the earlier questions, all they were doing, they were just giving us 2 points on a line. But you have to understand that those 2 points, they are coming from the same line. So if they give you the points on a line without the graph, you have to understand this is what it did. And if they give you the graph and then they ask you to find the gradient, you have to understand that I could pick any 2 points on that line, because no matter where I go on that line, my gradient is the same. My y-intercept will also form up to be the same. So after receiving those 2 points, whether you go on your graph and extract it, or if they give you it, you could find the gradient. Now, remember, if they ask you to find the equation, remember your equation, you need the gradient and the y-intercept. Sometimes they give you the gradient, sometimes they don't. So my first step is I could find the gradient, which is m. And there's a special formula we have to learn, which is if you're given 2 points on that line, I could label one as point 1 and one as point 2. Point 1 I'll label the x coordinate as x1 and the y coordinate as y1. And I could do the same with point 2, but using 2. My gradient is going to be y2 minus y1 all over x2 minus x1. So this is my formula that you have to learn. Well, not my formula, but the formula. And then you just substitute. So wherever I have y2, it's going to be 3. And wherever I have y1, I'm going to put 1. Wherever I have x2, I'll put 6. And wherever I have x1, I'll put 2. So I'll end up with 3 minus 1, that's 2, and 6 minus 2, that's 4. I could reduce this. So 2 could go into 2 once, 2 could go into 4 2 times, so that's a half. So my gradient of this entire line is a half. Now I know my gradient is a half, but you also know that I need to find my y-intercept C. Now, I don't know what's this, but I could use 1 point. It doesn't matter which point. Once it's 1 point from on this line, I could use any point I want on this line, or if they gave me 2, I could use any one of those to use the value of y and the value of x. So I could substitute it to use my algebra to find the C. So let's take this line, this point, sorry. Let's take this point here, where y is 3 and x is 6. Now I'm trying to find C. So I'm going to use my algebra in order to find it. So I substituted my value of 3, my value of my gradient. Remember, I found that. So I could substitute it. I could substitute my value of x, and we have to find C. So I could solve. 2 could go into 6 3 times. So I'll end up with 3 is equal to 2 could go into 6 3 times. I'll have 3 left here. 3 times 1 is 3. So I'll carry across 3. Because it was adding, when it goes across, it becomes minus. So it becomes 3 minus 3, which is C. So IUC in 3 minus 3 is 0. So C is 0. That means this line actually cuts the y-axis where y is 0. Right? So this line is actually supposed to be like this. Now remember, I did mine. When I did my line, I just took random values, right? So if I edit this a bit, that means that this line, it actually cuts I said actually cuts where y is 0. Now, what do we do next? I know my value of C. I know my value of M. So all I have to do next, in order to find the equation of this line, remember the y the y changes. So in the equation, we don't put in the value of y because the values of y and the x changes. However, your gradient is the same throughout. So we could substitute your m with a half. X changes, so x will remain a variable plus 0. But anything plus 0, I could just leave that as y is equal to half x. And that is my equation of this line. So just recapping. Straight line, they have a standard equation, which is in the form of y is equal to mx plus c. It could be y is equal to 2x plus 6. Y is equal to 4x. Y is equal to 6x minus 5. These are some examples of equations. But when we write the equation, your y and your x, they remain as variables in the form of letters. Next, your equation remains the same throughout that line. And because of this fact, no matter where I go on this point, on this line, no matter what point I go to, the equation is the same. The gradient is also the same. And the y-intercept, it's the same throughout the line because if I look at this line, it cuts the y-axis once. If I'm given a graph like this, I can select any 2 points on that line, or sometimes they might give you 2 points on a line. You can use those 2 points in order to first find the gradient. Using the formula y2 minus y1 over x2 minus x1. You substitute the values correctly. It doesn't matter which one is 0.1 or 0.2. Once it says that, let's say this was 0.2, it means that this will be x2 and y2. And if this was 0.1, it means that this will be x1 and y1. So once it is that it corresponds with respect to that, it's fine, it doesn't matter. After you find the gradient, you can substitute it into the equation of a straight line, which is and will always be y is equal to mx plus c. So you substitute the value of your gradient along with 1 point using the y and the x coordinates. And then you could find the c. Right? You solve for c as though it's a regular algebraic sum. And that's it. All right, so I'm pausing for a bit. Let's say they gave us a question like this one. They said on the graph below, the point P has coordinates, so they always have the x value first and then the y value after. Right, so look at this. So this is my point P here. They said write down the coordinates. Anytime they ask for coordinates, that means they want the x and the y value in this form. So in a case like this, what we'll do is we're going to go to our graph Remember, although my x-axis is horizontal, my x values are read vertically. So let's look at it. So if this is 2, this is 4, and this is 6, it means that in between 4 and 6, that line has to be 5. So it means that my x value, which goes first, is 5. And then my y value, if I look here, it's in line with -2. So my coordinates of P will be 5, -2. Then they said, through P, draw a straight line whose y-axis intercept is 4. Y-axis intercept, remember, that's where it cuts the y-axis. So it's going to cut my y-axis at 4. So all I have to do is through this, I want to run it through it so that my line is cutting through my number 4. That's all, yeah, that's it. Part 3, it says, calculate the gradient of the straight line. In order to find the gradient, you need 2 points on that line. So we have y2 minus y1 all over x2 minus x1. So I need any 2 points. Now what I like to do is I like to go for the easiest points. All right, so like they already gave us P. I'll go with easy to read. So like you see here, I'll read there. So my points, so I could have point 1 as my x value will be 0, right? Because remember, this is my y-axis, and at your y-axis, your x is 0. And at your x-axis, y is 0. So for my point 1, it's going to be 0, and then 4. So this could be my point 1, and this could be my point 2. So it means that this is x1, y1, and this will be my x2, y2. And I substitute it into my formula. So y2 is -2, minus y1 is 4, all over x2 is 5, minus x1 is 0. So it's going to be -2 minus 4. That will be minus 6 over 5 minus 0, which is 5. So my gradient will be negative 6 over 5. Or negative 1 1/5. And then they asked us to find the equation. Now, anytime you see the equation of a straight line, you just have to remember y is equal to mx plus c. Now, this is a lot easier this time because remember, in your equation, your y stays as y because that's a variable. Your gradient is negative 1 1/5 x. X is a variable, so we leave it as x plus c. And remember, c is your y-intercept. This time, I don't have to solve it because I know it. I know it's 4. So this now is going to be my equation of this entire line. The only thing that changes along the line is the values of x and y as we move from one point to another point.